Hey, it's 2 hours UTC, which means we are here for Astronomy Daily Live. Come on in, friends, gather around the circle, and let's talk astronomy for an hour or so. Turn off the TV, get away from the news. Let's talk about the universe. Let's talk about everything else except our maybe small problems down here on planet Earth. Although most things, do have a lot of importance, but for a while, let's sort of get away and think about telescopes and gear and CCD cameras and observing and eyepieces and binary stars and barred spiral galaxies and diffuse nebulae and anything else that y'all want to chat about. Hey there, Tom. How you doing? Hope everything's well with you. Everything's good here. I'm gonna pop out my chat, and before I forget, because I want to start increasing my uh, my times that I actually tweet that Astronomy Daily Live is starting now. So I've just tweeted that, and I'm going to do the same thing over on my Facebook page. So there we go. Yay. So hope everybody's doing well this this day. It is in terms of coordinated universal time, it is the 26th of March, 2018. Now, where I'm located, which is in dark and quiet southeastern Arizona in the United States, I'm 7 hours behind coordinated universal time. So for me, it is 7:02 p.m. And so, yeah, that's sort of a convenient time for me. Um, Before I started doing doing this daily live stream, I sat here at night, um, each and every night, thinking about astronomy anyway. So I sort of figured, hey, it's like, why not, you know, live stream. It's something easy, it's something fun, casual, no real plans, no real, set topics or anything. Gather in a circle of friends, see what they want to talk about. Oh, you just saw on the International Space Station, eh? Yeah, it's very awesome. You know what is very very cool. There's a couple of things. Number one, you know, as it's going overhead, you can think about the fact that there are people up there, um, floating around in that science laboratory. Um, I think there are there 6 people up there right now? Wasn't there just a rendezvous? I don't know if there are 6 or if there are 3, but regardless, as it's silently going overhead, and it takes about between like 5 and 7 minutes to go, completely overhead. Um, so as you're silently watching that go, you can think about the fact that there are people up there, and really, when it is directly overhead, it's a couple hundred, a few hundred kilometers up. So it's not really very far away. Um, and actually, with a moderately sized telescope, even a moderately sized pair of binoculars, you can see uh, the shape. You can see the solar panels and some of the structure and all that. And I think I'm going to take care of a kitty really, really quick. Hold on 1 second. Hold on. Oh, and Tom waved. Yeah, I always wave too. Yeah, but with a telescope, and maybe you've seen pictures of this. Uh, um, uh, uh, you can see, quite a bit of detail. So that's one of the cool things. The other really, really cool thing uh, that is sort of harder to catch um, is when there's a rendezvous, either before or after, right after. If it just so happens, that's um, one of the SpaceX modules, um, you know, just detached, or one of the Soyuz um, modules, doing exactly the same thing. It's really really cool to see, both of those objects up. One sort of chasing the other. It's very 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 cool. I was lucky enough to see. I think it was. Well, I mean, I've seen it. I've seen these kinds of things a bunch of times, but I'm recalling a time where I think it was one of the space shuttles and the Hubble Space Telescope um, were very 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 close to one another, and yeah, it's just very very cool, to see those kinds of things. It sort of makes it real, right? I mean, I'm I'm absolutely, convinced that, those kinds of things are actually happening, that they aren't, some kind of a simulation computer thing, generated thing, and we're being fooled into the fact, that that's actually happening. I'm totally on board that that is actually happening. But but to actually see it with these eyes, right? To look up at the appointed time, right? And see these things going on, that even makes it a little bit more real. And not that I need any convincing, but it's I don't know. It's sort of like a comfort, I guess. It's like, yeah, they're really doing it. So yeah, 6 people up there right now. So yeah, very very awesome. It takes the ISS about 94 minutes to go around the planet. So every 45 minutes they're either seeing a sunrise or a sunset, and yeah, though, and I've talked about this before. The people who are up there are there to work, and they are working. They're constantly, I mean, I think they pretty much have their schedules worked out minute by minute. I think there is some free time, but there isn't very much because there's a lot of maintenance that has to go on. There's of course all the experiments, always running a bunch of experiments. Um, uh, One of the things that sort of frustrates me, and maybe there not a lot is sort of publicly discussed in terms of what's going on up there, what kinds of experiments. They seem to be, I mean, this is just my observations, they seem to almost be doing the same thing over and over and over again. Now, that's not exactly true. They always have some new things, but they're always sort of sounds like they're doing the same things over and over and over again, and it's extremely cool. And that's sort of what labs do. This is a scientific laboratory. It's not really anything else. And in labs, what you do is you collect data, right? So just and the more data you have, the better, hopefully, um, uh, your understanding of things go. So, but yeah, it's extremely cool, to see those kinds of things. Make sure, if you haven't already, go over to Heavens Above. That's heavens hyphen above.com, and you can type in or select your location on the planet, and you can get the predicted passes of dozens of satellites every single day. A lot of them are rocket bodies, like second stages, third stages, that can be up there for weeks or months or years. Um, but a lot of them are just that, spent second stages, third stages, that kind of stuff. But you'll also get the International Space Station. You also get the Hubble Space Telescope, um, and communications satellites, um, um, uh, um, amateur radio satellites. Just tons and tons and tons of things. I don't know if you notice what I've got hanging up here. I've got a new drum. So yeah, thanks to a good friend for that fine gift. It's a good sounding drum too. It's small, but it's a good sounding drum, and I'm a sucker for a really nice drum. So yeah, that's a nice addition to my musical instrument um, collection. I guess that would be more of a percussion thing than an actual instrument. But yeah, that'll be very awesome. I love the drum. I have no training or anything. Not really interested in that. I just like to find some interesting beats and yeah, explore that territory, just sort of jamming. So cheers. Tonight is the hydrogen hydroxide night, so cheers. This is one of the most amazing, probably, I'm going to have to say, this is the most amazing molecule in the entire universe. It's just fabulous. So cheers. Mm, yep. Spot the station. There's also a site, I don't have it on the top of my head, but it's a site that will tell you when the space station is passing in front of the sun or the moon. And so, at the appointed time, you know, like with the moon, um, you can set up a video camera to be, sort of attach it to a telescope, um, and run the video, and at the appointed time, the space station goes by. I think it zips by in about a second or so. So at normal frame rates, 30 frames a second, you'll get 30 pictures. Excuse me, of the space station passing in front of the moon. And of course, if you have a solar scope, you can do exactly the same thing there. So probably at some point I'm gonna do that, and it's just it's one of the things that I've never done, never. I don't think I've ever really even seen it. Um, had a lot of times where um, I'll be out observing, looking at Meze objects or NGC objects or something, and looking at this faint blob, and I'll see a little thing shoot through the field of view, and it's like, yeah, it's probably a satellite. So yeah, there's a lot of those up there, and it's something that um, is apparently going to start becoming kind of a problem if Elon Musk has his way and essentially doubles or more the number of satellites in Earth orbit for his um, megabit megabit internet plan, which I will definitely sign up for. It's a great and awesome business model. I think everybody will want that. Um, but but if he throws 12,000, 15,000 more um, satellites into orbit, um, we're we're going to have two problems. One is when those satellites are being lit up by the sun. If somebody has some sensitive equipment that they've turned the gain all the way up, right? They've turned it all the way up. They're looking at this very very faint source and all that, and you have a bright, even I mean bright, relatively speaking, doesn't really even have to be all that bright um, in terms um, of magnitude, but you know bright enough you can damage equipment. Who knows? And then you've got the opposite problem too. When these satellites are in the shadow of the Earth, they're actually going to be passing in front of things and blocking them out. And that's a problem too. It's probably not as huge of a problem as being too bright, but yeah, you don't want these things blocking uh, your field of view, even for the microsecond that it would. It's yeah, that's just not right. So yeah, something. I that's a if they're able to successfully um, test this, and apparently they're doing that now. They launched a couple of these a month or so ago, and so if that seems to be a successful thing, and they're able to throw 12,000, 15,000, 20,000 of these satellites into orbit. um, I don't know, ground-based astronomy is, I don't know, we're that's essentially doubling at least the active satellites that are up there now. That there's a lot of stuff out there. There's a lot of stuff. There's probably, just a rough estimate, 20,000, 30,000 things out there right now, from nuts and bolts and gloves and shoes to rocket bodies and operating satellites. But yeah, and it's a I don't really consider it a problem right now. Um, but if you double the number of satellites up there, then your problem doubles as well. So um, I don't know. It's an interesting problem that needs to be dealt with. because as I said, if they're successful, then people are going to want this. I mean, I'm raising my hand, and if people want it, then they're going to do this. And how is that going to impact ground-based astronomy? I don't know. That sounds like it's going to be, I don't know, a little nasty. Not sure. Not sure. So I hope you enjoyed today's or this week's Music from the Hearts of Space. This is a weekly radio show. It comes out, I guess it comes out every Sunday, and every Sunday, it the the um, the weekly show is free. You can listen to it all day on Sunday, and what I end up doing is I end up recording it and listening to it later. Now, is that violating a copyright thing? Probably is, but you know, I'm using it uh, for my own uses. I definitely, I don't really even share it, right? I tell people about it, and it's like, go listen to that because it's really really great. Um, Most of the time, their shows are really really awesome, and if you like space music, or sort of the ambient, spacey type of stuff, definitely check them out. It's hos.com, and they've been doing this since like the early 80s, and they went nationwide I think in like 85. So they've been doing this for like 30 plus years. And uh, I think yeah, today's show was program number 1176, and they've repeated a lot of their shows. So I would say probably a third more, half more or so, maybe getting around 1,500 or 1,600 actual shows. You could work out. Let's work that out. Grabbing the handy dandy calculator that all good scientists should have. So 52 weeks a year, and they've been doing it. Let's just say for 30 years times 30. Yeah, so that's 1,560 weeks. And as I said, they're up to, in terms of unique shows, they're up to 1176. So they've repeated shows 384 times. Um, but, they repeat shows, don't exactly know why they would repeat a show, except, maybe they ran out of time, weren't able to, produce a new show. Maybe somehow, although I find it almost impossible to believe, maybe they weren't able to find anything too interesting. I'm sure that they like to do variety, and not have the same artists on every week after week. Um, I don't mind that at all. But yeah, so check them out, hos.com, Music from the Hearts of Space. It's if you're out observing under the clear dark night sky, you can turn on some space music and just drift away, and it's very very awesome. It's very very awesome. I remember um, uh, being up at the 61-inch telescope up on um, Mount Bigelow, just north of Tucson, and this is a telescope where the if you're using it, you're also telescope operator. You're also collecting your data, all of it, right? Sort of a one-person show, and so I was doing photometry of white dwarf stars, and so taking relatively long exposures, um, and so I would turn on music from the Hearts of Space, and I would sit inside of the dome at night. I had to be out there with the instrumentation. I couldn't be in the control room because all the instrumentation and all the computers were right there. I was using a K-Pro computer running CPM, and that program talked to a photometer um, that simply counted photons. So, line up the telescope, get your object in the field of view, um, flip your mirror out of the way, the photons fall onto the photo multiplier tube, and produce an electronic signal, which then the software is able to pick up and say, "Up, there's a photon. Up, there's a photon. Up, up, up." And for faint sources, uh, yeah, you'd have to do several minute exposures, and so it was really awesome during sort of those waiting times. 1 o'clock in the morning, 20 degrees, crystal clear skies. Um, to sit out there in the dark dome, watching the photons accumulating and listening to music from the Hearts of Space. It was just nirvana, absolute nirvana. It was great, and yeah, so definitely check those guys out. So the other, I actually signed up for this other site um, almost a month ago, and I forgot about it until um, today. So I'm going to share my screen. Have to go to infinity first. There we go. This site is called. Oh, here's music from the Hearts of Space. So their latest show is called what's it called? It's called Electron Traveler 3. So as I said, I just recorded it um, today, and sometime during this week I'll listen to it. This one sounds particularly interesting. Sometimes I don't like much of the music that they play, but that's pretty rare. It's pretty rare. This one sounds very intriguing. Um, so yeah. Anyway, so the forum that I found it's called cloudynights.com, and this is an amazingly active forum. I mean, really busy, and a lot of conversation, a lot of topics, a lot of information. So, as I said, I signed up for this almost a month ago, and promptly forgot about it until today. And I don't remember what reminded me of this, but this is very awesome. And you bet, I will be making contributions to this forum. These are definitely my people, and you know, uh, not only for me just as an astronomer, but also for um, this live stream for Astronomy Daily Live. I think this is the audience that I've been looking for. So they seem to be very active, very knowledgeable, uh, friendly, helpful. And that's of course been my experience with the astronomical community, is that we like to talk about astronomy a lot. and any opportunity that we can, we will. So yeah, if you're a beginner or an amateur or an advanced amateur or a pro, just like Astronomy Daily Live, going to cloudynights.com is a great resource. And it just, there's a forum for beginners, general observing, equipment. Look at all the equipment stuff, uh, talking about observatories, reflectors, refractors, astrophotography, and sketching. There's even a, um, uh, oh yeah, okay. Um, Here's all the observing stuff, and different sections, right? For different kinds of observing. Um, there's an interesting forum. I have a Nexstar. I have a Celestron Nexstar 8 SE, so I'm definitely going to be following the topics in that one. There's astro-art, websites, conferences. I It's just, and it's very active. You look over on the side here to see when the last post was, and it's like today, and maybe minutes ago, right? So yeah, it's a very active community, and it blows my mind. Some of these people have 5, 6, 7, 8,000 posts. And it's like, wow. So a very active group. You better believe I'm going to be making contributions to this forum because, yeah, as I said, these seem to be my people, and they're probably yours too. If you're watching this is probably your crowd as well. So get on. I think when you sign in, it isn't automatic. You have to be approved. Um, don't remember if they ask any questions. Sometimes forums will ask, what are your interests, or something like that. Mainly, just to make sure that you're not some kind of a bot or some kind of a jerk who just wants to come in and cause trouble. Although I've seen a little bit of that here, but not very much. Not very much. So just um, let's see. Let's update this because I loaded this prior to coming on here. So just within the last half an hour, these are new topics. So these aren't actually just replies. These are new topics. Um, my M63 story. My M63 story. Let's go and see what uh, Fireman Dan, okay, who's posted. He he's been on since 2014. Has posted 4,401 times. He's talking about my M63 story. Decided to go to the genre before. Enjoyed the dark skies. I planned on what targets I wanted to shoot. I hope to get at least 8 hours of data on M63. Arrived Wednesday, heavy wind, snow, picked a spot, set up the mount, and then the tent. Uh, Wind made things tough, of course. Wind is going to shake your telescope all around. It doesn't matter how sturdy of a mount uh, you you get. But in the end, let's see, uh, guiding some high level clouds rolled in. The guiding was terrible. The cold, it was cold. He was tired. Um, uh, so he went into his tent and he popped his head out after a little while and it cleared up. Um, uh, so yeah, I just he he had to sort of give up before the sky opened up, and in the end, he got a pretty nice looking result there. It looks like. Wow, not bad. Let's see. Telescope imaging or lens TPO RC8 imaging camera. Oh, I'll log into my Linux machine again here. So overall, I mean, it goes without saying that I'm really, really, really impressed with with this uh, with this forum. This seems to be great place. I love the name cloudynights.com. It's like you know you know most astronomers do experience from time to time cloudy nights. And when you have a cloudy night but still want to do astronomy, what do you do? What do you do? Well, look, go on to cloudynights.com and there you go. So yeah, very very awesome. So M63 story, Horsehead Cannon, M10, just on and on and on. Here's name that scope. Name that scope. Let's see. This is a snippet from a much bigger picture of the whole telescope. Which one? Okay, so he's he or she, I'm not sure, posted 11,034 times, been on since 2004. Uh, so here's a snippet of what looks like a telescope mount, looks like an alt-az mount, um, mainly because I'm just seeing sort of a flat surface here. Hard to know for sure. There's some color here. Oh, I don't have a clue. Don't have a clue. Does anybody else have a clue yet? Nope, not yet. So it it's just fun, you know. That's really fun. Anyway, so check these guys out for sure. Now, I wanted to give a update to my project. I do have an update. I do have an update. It's a good news update. Let me uh, let me indulge here. Cheers. So this telescope that I have here. This is my Celestron Nexstar 8SE. I also have a CCD camera. It's an S-Big ST7ME. Uh, old school, old school, parallel port, um, running on a Windows XP machine that is running a piece of software called CCD Soft 5. I'm going to be looking into sort of a newer piece of software that may allow me to auto guide. I'm very, very excited about that um, because one of the problems that this scope and all scopes have is that even if your star tracking model is very very good, you're still not going to be able to track very very well. So if you want to do long exposures, to be able to image or see faint objects, faint stars, whatever it is, um, you uh, you have to be able to do long exposures, and the nothing can move, right? Because you're trying to do an accumulation of um, photons, right? And so two things can be done with that. The first thing is that you can set up a guiding system, where you have, you know, sort of a separate system where it actually tracks or notes, you know, the position of like a selected star in the field of view, and you tell it, okay, I want you to keep that star there, right there. So as the telescope tracks, if there's any kind of tracking errors, that star is going to apparently move, right? Move around. And what the guiding does is when it notices that the star has moved a little bit, it'll actually send a signal to the telescope to, you know, to move a little bit and put that star back uh, where it is. And if that star is where it is, then whatever target you're wanting to take a picture of will also stay in the same place. And so you can do a long exposure, you know, minutes, hours, um, as long as you're able to guide. Uh, so that's very very awesome. Um, but at the moment, I don't have that option. So you know, the tracking on this sort of limits me to maybe 2 3 second exposures. But what I can do instead, right, is I can take a series of exposures and not worry too much about the tracking, because you know, with a 2 3 second exposure, uh, it's not a problem at all. 5 seconds, 10 seconds, then I start to see, you know, little streaks. Don't want streakers. Um, so, but, you know, with a 1 2 second exposure, not a problem at all. So, what I can do is I can actually, uh, uh, you know, take a series of these short exposures where, you know, the star field is here, and then it's here, and then it's here, and then it's here, and then it's here, and it's, you know, little tracking errors, right? But what I can do is I can re-register all of those. So I can say, okay, take the first image and use that as sort of a reference and say, okay, I want all preceding um, um, images to all stack on top of the first one. And that works really, really well, except except that this telescope is using an alt-as mount. So what that induces in the image is field rotation. So over time, you'll actually see the entire field of view rotate. You'll see the same field of stars, right? But over time, they'll appear to rotate. So when you try to stack those, okay, you'll just get these, you know, these long streaks, which is cool. But if you want to be doing, you know, photometry um, or astrometry, which is primarily what I'm going to be doing with this guy, then I don't want streaks. I want those um, stars, say, to be nice round peaks, ideally, you know, points. Uh, so uh, so my my task over the past couple days or week or so uh, has been to do that, to not only register these things, but also apply rotation, to, you know, to take out the rotation. And you know, the stacking part, you know, the registering part is easy, right? I say, okay, that star right there, I want to use as a reference. I want all all the other images um, to stack onto that star. So you find it in the first image, find exactly the same star in the next image, take that next image, shift it, and then add it to the first. And then you take the third image, find that same bright star, reference star, shift it again, add it. Easy peasy, right? But I also had to be able to rotate it like that. And the past several days, I've been struggling with that, and it turns out that I'm just too much of a purist. I was looking for something that, in hindsight, it's like, oh yeah, of course. So I actually had the solution a few days ago and just didn't know it. Just didn't know it, and but once I realized that it's like, okay, this is working, then I was able, to finish this whole thing up, which meant um, actually locating two reference stars. So take the first image, find two stars, and measure the angle between them, right? Then take the next image, find those same two stars, and measure their angle between them. Now, because of field rotation, right, the angle between um, those second two stars will have changed relative to the angle between the first two stars, just slightly, right? Um, but it's enough over 20 images, 30 images, 100 images that you're going to see it. So so measure the angles, and then I calculate the difference in the angles between my first image, my second image, and then I slightly rotate the second image, shift it, and then add it like that. And so I did that for all 20 images in this case, and yay, it worked. It worked. It worked really, really well. Um, Increased my signal to noise by at least a factor of 20. And so now what I have to do is take that stacked image and do photometric analysis on it, um, where I look at the differences in magnitudes between the stars in the field of view. I'm using Messier 41. Better late than never, Uncle Bill. Hey, hey, hey. Wave, wave, wave. Painting the place yellow as usual. um, and so, yeah, now I have a stacked, rotated image that looks really, really good. Really, really good. Signal to noise is much improved. So now what I have to do is photometry on that. And so what I'll do is I'll measure the differences in magnitudes. Again, I'll choose a reference, usually like the brightest star in the field of view as sort of a reference. And then I will I'll measure and calculate the difference in magnitudes between all the other stars and that reference star. And then I'll compare those differences to a catalog that has the actual magnitudes um, and magnitude differences, and see if my accuracy has improved. I'm hoping that with better signal to noise, that my accuracy will be much, much improved. Now, with a single 2-second exposure um, on on a 11th magnitude star, I was getting an accuracy of about maybe about 2/10 of a magnitude. So I was about 2/10 of a magnitude off from what the catalog said. But my precision was actually very, very good. It was like 50 millimagnitudes, so 0.05 magnitudes. So pretty consistent, but just not accurate enough. I would like the accuracy to be less than 1/10 of a magnitude. And so what I'm hoping now that I'm able to properly stack um, several images together is that I will be able to achieve that. So that's what I'm actually going to be doing after this live stream tonight. I just finished uh, the software prior to coming on here, and yeah, I feel as though I've been running a marathon. So it's just like exhausted, absolutely exhausted. But I'm pretty anxious to see what the photometric results are going to be. So what I can do, I've got a series of images of M41, M46. I probably have a total of about 100 images or so calibrated, and so probably what I'm going to do is, a little bit of experimentation. They sort of I collected these in sort of blocks of 20, just sort of arbitrarily chose, you know, 20 at a time or so. And so what I'll do is I will do the photometry on a stack of 20. I'll do photometry on 2 stacks of 10, 4 stacks of 5, 5 stacks of 4, maybe 10 stacks of 2, just to sort of see, because I'm really, really interested in precision, in consistency, and I want to see how the accuracy and precision changes as I increase or decrease the, well, I guess effectively the signal to noise, how many images I use in the stack. But yeah, I'm so happy. I'm so happy that the shifting, well, actually the rotating, shifting, and adding is working now, and works really, really well. You know, stars that aren't really visible uh, in like a single frame just pop out in this um, stack of 20, which is expected. That's exactly uh, what you would expect. So cheers to that. So yeah, I'll probably probably be posting some information about that on my Discord server tomorrow morning or tomorrow night. Um, as I said, I've been worrying about this for about a week now or so, and as I said, I was looking a little too closely, and I had some expectations that were just completely, I think about it in hindsight, and it's like, yeah, sometimes I overthink stuff, and this was definitely a case of that. So, but that's behind now. I've got some working code that is working really, really well. It's actually really, really cool. I pulled up some um, 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 some subpixel shifting and some centroiding software that I had written 20 plus years ago, and so I'm using that because it's the same. It's exactly the same thing, same problem that has to be solved. So it's really, really nice to be able, to dig up some old code and, just basically cut and paste it, and it just works, right? Very, very awesome. Uh, so yeah, very, very cool about that. As I said, I will be posting results on that. Good or bad. I don't really know what to expect now, so because I'm still not exactly sure why my accuracy was how it was. Um, the differences in magnitudes that I was getting are all consistently less than what the catalog differences are. So I'm not quite sure why that would be the case, because if it was sort of I would think at least that if it was sort of a random distribution, then the accuracy, uh, uh, sometimes my measurements will be a little bit more than what the catalog says, and sometimes the measurements are going to be a little bit less. But that's not what I'm seeing. I'm seeing a few that are more, but most of them are less. And so that to me is a red flag saying, you know, there's some kind of there's some kind of a systematic thing that I'm not taking into account, or something in the process, something in the software, something in the calibration. I don't I I don't know. So I'm hoping that with better signal to noise, that the measurements of the brightnesses will be better, in that the accuracy will be higher and the precision will be lower, um, accuracy lower as as well. Yeah. So let's see what else. Cheers. Hope everybody's doing well. Hope you have some clear skies where you are, clear and dark skies. It's been pretty stormy here, so definitely no clear skies. It's always very, very dark here, though. I guess we have a moon at the moment. Is it pretty close to first quarter now? Yeah, something like that. We're gonna have to talk about the phases of the moon at, at some point. That is definitely beginners territory, but definitely worth doing, because seeing the phases of the moon and how they change, that's I know for a fact is oftentimes very, very confusing, to somebody who doesn't understand the perspective that we have in terms of looking at the moon, and why should there be phases, and are what why do we see the phases that we see. A lot of people think that we're somehow looking at the shadow of the earth on the moon, and how at first quarter it's exactly flat, and it's like, what is that, an edge? I don't know. So yeah, we should talk about the phases of the moon at some point. I was very, very pleased. Um, Pulled up Stellarium um, um, tonight, and was able to load in from the Minor Planet Center. I was able to load in the asteroid Nele, Nele, and that was an asteroid that uh, we talked about last night, and I was able to load it into Stellarium, and gotta gotta understand it well. Yeah, I haven't really checked into it enough, but once it's loaded into Stellarium, um, um, what I noticed is that it's almost in conjunction with the sun right now, making it not only impossible to see because the sun is in the way, but it's also as far away from the Earth as it's going to be. So, I'm sort of thinking, okay, it's really, really faint. Can't see it anyway. I think Stellarium had it at magnitude 15.9 right now. Plus, it's looking right into the sun, right? So there's no way, to see that right now. So it's like, okay, well, probably in 6 months or so, when the Earth has, swung around, um, Nele and the Earth are going to be closer to one another, which means it's going to appear brighter. And it turns out I don't think I saved it over here, but sometime in November of this year, Neely is going to be near opposition, which means it's on the other side of the sun from us point of view, but it's also the closest that it's going to be to Earth, which also means it's going to be about its brightest. And I think Stellarium predicted that it would be about magnitude 12.8 or so. So that is bright enough. That's bright enough to see in this scope. And so, um, you know, do a series of exposures, uh, stack them up, and then should be able to watch this thing move. And yeah, so that might be interesting. Get some filters on there, see if we can see any kind of color. Uh, these are, from the paper last night, the albedo, the reflection of these things is actually very, very high, relatively speaking, which I think sort of implies that they're relatively new or relatively young. Um, Asteroids. But so yeah, I might make some plans to observe the asteroid Nele, which is part of this family. I think of like 384 asteroids or so. Is that right? Uh, waxing gibbous. Yeah, yeah. Where'd they come up with these names? I don't know. I don't know. Um, but yeah, so should be able to see that. Should be able to capture some um, pictures of that asteroid. Uh, it'll be now it's a pretty eccentric orbit, so I didn't look to see how far away it was going to be at that time. What I'll have to do is go on to the minor. Hey, let's do that. Let's go on to the Minor Planet Center and get what's called an ephemeris, which is nothing more than just the location, not micro, minor, minor planet center, which is just it's going to show us the location of whatever target we're interested in over a period of time. So what you can do, you can go to the Minor Planet Center, right? Go to Observers, go to Ephemeris Service, and down here you can type in the name of your object, which is going to be Nele. And I'm just going to give a rough latitude and longitude here. Let's see, we're going to start on, let's go 2018-11-. 1. And let's see, we're going to go maybe let's go every 4 hours. Every 4 hours. So let's see, over the course of a week, let's see, that'll be six times a day. 6 times 7 is 42. So let's go 42 dates to output. Okay. I'm just going to do a very, very rough longitude and latitude here. 32 latitude, altitude doesn't really matter, but I think that's what I am. Everything else you can leave exactly the same, because what we're going to be wanting is just the um, equatorial coordinates and the magnitude, and that's what we will get. We'll get the right ascension and declination and the magnitude, and I think a bunch of other stuff too. So let's just see. So this is for the week starting on. I think I've got this order correct, on November 1st. So we're going to go from November 1st to November 8th. Every 4 hours, it's going to pump out a right ascension and declination. That, I think I did that right. Yeah. So 2018, 11/1, at 0 hours UTC, 4 hours, 8/12, blah, 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 blah. So yeah, so you can see here's the right ascension, 4 hours, 41 minutes, 40.4 seconds, and a declination of plus 39 degrees, 15 minutes, 47 seconds. I think, I don't remember. Let's see, do they say? No, they don't say. One of these, I think it's R. I think that's the distance between the observer, me, and the asteroid. So it's about 2 astronomical units away. Visual magnitude 13.5. So I'll definitely be able to see that. You can see that it's moving. It's moving, and it's actually accelerating, right? But it's moving about what, 0.2 arc seconds per minute or so. It gives other information about the phase of the moon. We definitely want to maybe observe this during new moon, so that's a phase of 0. So towards November 7th or so, it'll be nice and dark, and it'll be relatively bright. So let's see. Let's go one more week, because it looks like it's getting brighter. In uh, in astronomy, the smaller the number, the brighter the object. So see, it went from 13.5 to 13.4 to 13.3 in this last one. So let's go another week. Let's go another week here and see. See if it coincides with what Stellarium said. So 13.2 towards the end of, or towards the middle of November. Let's go one more week. I noticed that I'm past our hour here. Man, it goes by so fast. I don't know if it goes by that fast for you folks, but it sure goes fast for me. Must mean I'm having a good time. 13.1, 13.0. Ooh, it's still getting brighter. Okay, let's keep. What I can do is I can just I can increase this one. Let's go like 84. Double it. Ooh, 12.9. So yeah, that coincides, I think, with Stellarium pretty well. And as you can see, yeah, I don't remember I'm sort of thinking that delta. I'm sort of thinking that delta is the actual distance between the observer, me, and the object, and r is the distance between the object and the sun. So it's 2 astronomical units from the sun and 1 astronomical unit from Earth, which is right. It's really, really near um, um, opposition. So yeah, I'll definitely be able to see this guy. And as I said, we should probably look at it when the phase of the moon isn't full. So probably don't want to be observing it mid-November. Probably want to do it. Looks like early December. Let's see. Let's go one more here. You just get totally lost in this. What, 29? It looks like going into December. Going into December, 12.8, 12.9. Okay, so here we go. So this is as close as it gets. This is opposition, 1.022 astronomical units. Phase of the moon. So here's new moon. So come December 7th, 2018, I I want to try to remember at least to do some imaging of this guy. Looks like too he'll be moving pretty fast. Uh, 0.6, 0.6, 0.7 arc seconds per minute. Hold on, I gotta let a kitty in. So yeah, over the course of an hour, right? Over the course of an hour, this thing, let's see, if it's moving 0.6 arc seconds per minute, over the course of an hour, it'll have moved 36 arc seconds, which for me is about 36 pixels or so. So I will definitely be able to notice that motion, and if my astrometry is good, I can actually calculate velocity myself from that data, and yeah, that you know compare it to predictions, and yeah, very cool. So all right, I am past my time, so I am going to stop sharing my screen. I'm going to pop back on here just long enough to say peace, cheers, have a great evening, a great day. If you're just discovering this live stream for the first time, make sure to subscribe, um, hit the thumbs up or the thumbs down, whichever you prefer. Make some comments if you have any questions, any kind of topics that you want to talk about. Let me know. There's always something to talk about when it comes to astronomy. So yeah, let's do this again tomorrow. So far, my experience has been that tomorrow has come. So I will see you again in less than 23 hours on about 20 million kilometers. I don't know which way. Some some way. At some point in time and space, we will meet up again, gather the circle of friends, and talk about a common passion, astronomy. All right. Take care, everybody, and I will see you on the spin tomorrow.